Here are what I think the 5 most common mistakes in software design that make your code base and system a nightmare to deal with. I'm Derek Martin from CodeOpinion.com, and of course I'm going to give you ways to avoid these mistakes. So let's get into it. The first mistake is related to data, being in an invalid state and having data consistency issues. And this happens because you don't have good control over what's changing state. To illustrate this, let's say we have 2 different boundaries and we have billing here reaching out, let's say changing state of another boundary. This cannot happen. We need one particular boundary to be the authority to understand that all the state changes are always going to be valid. We always want our data to be in a valid state. And if you're in a monolith, it's the exact same situation. You need ownership of what's actually controlling the state. This cannot happen. You can't have one particular part of your monolith just a free-for-all and being able to change any state anywhere in the system. I'd like to thank Kurrent for sponsoring this video. Kurrent's an event-native data platform that feeds real-time, business-critical data with historical context and fine-grained streams from origination to destination, enhancing data analytics and AI outcomes. For more on Kurrent, check out the link in the description. The mistake is not having ownership, and if you've had this situation, you know the pain of, well, how did we get into this state? Why does the data even look like that? That's completely wrong. How did that happen? You have no idea, because you have no idea what actually changed the state to begin with. Was it somebody manually connecting to the database? Was it another service completely separate or another application that was integrating that was changing state? Who knows? Because you have no ownership. It makes it a nightmare to deal with. And the solution is to define ownership and specifically define an API that other parts of your system can interact with. That's the contract. So when you want to say, okay, I need to do something, you're invoking that API. It's the one under control. It's got the ownership. So there's one specific place that's making a state change. Really what we're doing is we're defining commands and queries because they're both equally as important. I want to make some type of invocation to make some state change. I'm calling this particular command. That's how I do that. I want to get out some type of data related to that particular section of the system. I call the API. That's a query. Everything has this funnel, that one particular place that has ownership over commands and queries. It's not a free-for-all. And this segues perfectly into the next mistake, which is your code base not being explicit. Meaning it's oftentimes very implicit because it's driven by CRUD, create, read, update, delete, in entities. If you look at the code base, can you really tell what it does? What are the capabilities? If it's just driven by CRUD and entities, you oftentimes don't really know because it's really your end users that are kind of driving the workflow, and none of that is really captured. So your code base is kind of very implicit about what its actual use cases are. Just as an example, I'm going to use an event to illustrate kind of what I'm talking about here. So we all know in large systems, you're going to add functionality over time, and oftentimes you want to be reactionary. So that's why I'm using an event just to illustrate this, just to get my point across. If we had some type of CRUD, and we're talking about a shipment, where one of the things that has to happen is the driver for a particular shipment has to go pick up the package. So when they do that, oftentimes you're giving a bill of lading, and that's the BOL listed here. So let's say we're just using CRUD. We have to enter the BOL, a part of our shipment. So derived from that, when we did that, would be this event, that the shipment was changed. Some data was changed for some shipment ID, and we know the bill of lading. Why did the bill of lading change? We don't know. We just know that the shipment changed, there was a bill of lading entered. Maybe they re-entered it, or was it because we actually entered it the first time because we actually picked up the freight? We have no idea. There's a big, very, very big difference between a shipment changed because it's just CRUD driven, or that the pickup, that particular stop, the freight was loaded, so we have a pickup stop loaded with the shipment ID, the particular stop, the date time, the bill of lading, maybe some more information. This is very, very different than just kind of that CRUD driven. This is explicit. This is implicit. And the reason I illustrate with this an event is because it's the tail end of everything. It's what happened. How did we get there? Well, you'd want to be very explicit about what the user's interactions and what the actions are that they can take. So it's a part of workflow. If it's just update shipment, and that's kind of like, oh, you're doing a REST API with a patch or a put, well, what are they actually updating? You don't really know what they're trying to do. You don't really know a part of the workflow. So then you're trying to infer or imply based on data changing, maybe what you want to do after the fact about, okay, this data changed, then I need to do something. But oftentimes not that data changed, that's why it changed. So be explicit. You'll be able to navigate your code incredibly easy rather than trying to infer everything. And now you can tell how you can avoid these two first mistakes hand in hand is that if you have explicit commands, that's what's responsible, that's what has the ownership of making sure some particular state is valid. The third mistake is not realizing when you're adding indirection because you think you're just doing a good thing by single responsibility often, and it's not really the case. So when I'm talking about indirection, we have some caller to some target, and we're just adding something in between because we deem, well, okay, maybe it's a little bit more focused and responsible on what it needs to be. The easiest example of this is data access. Oftentimes you'll have some type of caller that needs to call some data access layer that's going to manage all the data access, and even more typically then it's calling some type of ORM or some third-party data provider that actually ends up hitting our database. This looks simple. The reality of it is it's not usually this simple. What it really ends up looking like, if we're in some type of web app or HTTP API, and I'm simplifying this often, we have some controller that's calling some other class that's some dependency, and then hidden behind that, it has another dependency on some other class that's some other service that we have, and it needs to do data access, but not just stop there. It uses some helper extension method or function that it has, and then that's the thing that's actually hitting the ORM, and that ORM is actually hitting our database. This is probably even simplified then about how much indirection is really happening when we make a request. The mistake isn't indirection. It's just not being aware of the indirection you're adding and if it actually provides value wherever you're using it. The typical example of this is adding your own abstractions. So if you have calling code that's highly coupled to some abstraction that you created because you want to kind of hide or minimize the API of some third-party dependency, this could be a totally valid use case for that abstraction. But realize you have that high degree of coupling, and that's something you got to manage. Let's say in this case, you didn't have a high degree of coupling, and it's just like really one spot where you have your code that's dependent on some abstraction that's dependent on some third party. Well, is your abstraction really worth it? Did you really need to create that indirection? Don't create useless indirection. It makes it so much more difficult to navigate a code base when you're trying to look at a request to see what's the entire code path that it takes and having to navigate all that. We probably all experience this and we agree it's very difficult. And oftentimes that indirection just doesn't need to be there. Specifically if you have what I call useless abstractions. Abstractions are very useful when they provide value. When you're trying to simplify an API service, or you know that you're going to have multiple implementations, so that's what you're using it for, to kind of hide or simplify something. But oftentimes you see abstractions that are completely pointless, that are serving no value, and rather you'd be better served kind of managing the coupling you have to something that you're trying to hide or simplify rather than creating that abstraction. So just the focus around this is just really pay attention to the indirection that you're adding. And that leads us right into playing the what if game is the next mistake. What if this? What if that? And this is kind of like the idea of like not following Yagni really is playing this what if game. But it's kind of two-sided. There's also on the feature side of, okay, well, we're developing this feature and what if somebody requests a similar type of feature that's kind of slightly deviated from this? Well, what if? Nobody's asked you. So how do you even know if it's going to be valuable or not? But this is also on the technical side as well, as you're writing some particular code and it's related to some feature or something infrastructure related, and it's going to work for this one use case, but what if we need to change that? What if we need to change the technology? And this is why you stumble upon that in-house framework code or that very generic code that nobody really understands, nor should it exist because there's only really one given use case. Or, like I was mentioning before, of how you end up with this useless abstraction. Don't play the what if game. Now, having said that, that may seem contradictory of, well, you want to be able to evolve your system, evolve your architecture. There are ways to do that without playing the what if game. I'll have a link to a video I've done about exactly that, about giving yourself options to evolve your system because it relates to doing it at a low cost. The issue here is not so much that what if cost of development, is when you build this stuff, you have the cost of ownership. You're dealing with that code, the coupling you've caused with that code. If nothing's even using it, there's really no value behind it. All that code has a cost. And the biggest one really isn't so much that initial development, it's the cost of ownership to deal with it and maintain with it going forward. So the last mistake is really not managing workflows. This is a little bit more advanced because you've kind of got along all this way of kind of identifying and being explicit about the operations. And then the thing is that you need to realize where you have workflows and how you're managing them. So let's use a really simple example of placing an order. You go through some checkout process, you place your order, you do at that point process the payment, let's say you charge the credit card. After that's successful, you want to send out an email confirmation to the customer that just placed that order. Sounds great. That's pretty simple. That's kind of our workflow. The problem is when you're thinking of this as kind of one thing rather than it actually being a workflow. And instead of just being a long procedural set of code. So you place your order. Well, what happens when you try to charge that credit card and it fails? What does your code look like? Again, if this is all very procedural, are you capturing exceptions, kind of error responses? You can only imagine kind of what that tree of that code block looks like to how to navigate that. Because after you fail that process payment, do you want to cancel the order? Are you sending them an email? Are you showing it in the UI? How are you dealing with this? So the biggest thing about workflows really is to not think of them as kind of one linear thing grouped all together and even visually in code of thinking of it that way. It's rather thinking of them as small units that you can execute isolated by themselves and let that kind of workflow flow from one step to another step. Now, like I said, this is a little bit more advanced because understanding that you have workflows, using tooling to kind of deal with workflows in isolation, using queues, messaging, etc. This is not trivial. I get it. If you followed any of my videos on YouTube, you know I have a good segment of videos that are related to messaging, so you can follow those around. But the point of this about the mistake is not really realizing you have workflows. It's great that you have them, but how you implement them in code is going to be night and day difference if it's very procedural, how you're kind of managing exceptions, errors, all the different code paths that need to happen, especially when these get complicated. Kind of not realizing that but using the tooling that's available, because there's a ton of great tooling out there to kind of manage messaging, workflows, etc. that make this a lot easier than oftentimes what I've seen in the past of code paths that are wild about all these different conditions on if this happens and this happens, which goes back to all this indirection. So really recognize that if you have workflows, kind of different ways that you can manage it with other types of tooling that are specifically built for this. So in my experience building large business systems, these were what came to mind about kind of the common mistakes that I often see and that I've made myself. But get in the comments and let me know what you think are the most common mistakes or things that you've experienced yourself, that you realize are mistakes, or that you've seen in other code bases that you think I missed. Get in the comments and let me know. And of course, if you want to chat with other software developers about software architecture design and about some of these mistakes that you want to try to avoid and get some suggestions and feedback, you can join my channel and get access to a private Discord server. The link's in the description on how to join. If you found this video helpful, please give it a thumbs up. If you have any other thoughts or questions, make sure to get in the comments there. And please subscribe for more videos on software architecture and design. Thanks.